In this example, we're going to factor this quadratic trinomial, and it does not look like there's a greatest common factor that I can pull out to start with. So let's just go ahead and multiply my a and my c together. So the a is the leading coefficient and the c is the constant. So 35 times negative 1 is negative 35. So when I multiply to get a negative, I know that one of these signs of the factors have to be positive and one has to be negative. And of course they're going to add to make negative 2. So factors of 35 are 1 and 35 and 5 and 7. And since they added to make a negative, I know the larger will be negative and the smaller will be positive. And which of these pairs adds to negative 2? Well, the positive 5 and the negative 7. So let's go ahead and rewrite the first and last terms. And what we're going to do is go ahead and take this linear term in the middle and split it up into these two factors. So it'll be positive 5u and negative 7u, and it's based on these u terms, so they're like terms. And we're going to go ahead and now use factor by grouping. So from the first pair, it looks like we can pull the 5u out. And when I do that, it looks like 7u plus 1 will be left over. And here in the second pair, I have a negative 7u minus 1. So it looks like I'm going to pull a negative out, and it looks like the greatest common factor then is just negative 1. So I'll have left over 7u plus 1. Now, some students struggle with this piece right here when the greatest common factor is 1, but we pull the negative out. So make sure we write the negative 1 right here because it's going to matter later on. So the leftovers are 7u plus 1, and I can factor that out. And then my greatest common factors were the 5u minus 1. And that's why you have to be really careful with the way you write this greatest common factor, is because he matters right here in the 5u minus 1. So here is the final factored form, quantity 7u plus 1 times quantity 5u minus 1 for this initial quadratic trinomial.